free Unix descendants, which are less known than Linux, which a lot of people have experience with. If you don't have experience with Linux, that's okay. This will just be an added bonus to you. I'm going to go ahead and just get started with a chart, which the resolution is too low for you to see. But you can see these colors. We got green, yellow, and red. Now, yellow up here, this is the beginning of old Unix, the beginning of time in 1970, right? And you see these lines, hopefully. These lines are lines of inheritance. So this leads to this, leads to this, leads to this, which leads back. And that's part of what I want to talk about. Over here, we've got things with no lines back to the original. This would be Minix and Linux over here. And one of the themes of my talk is going to be talking about how BSD and Illumos directly trace themselves to AT&T Unix and the amount of collaboration, which is really interesting because with these operating systems, you have different teams with different visions and different goals, but they're able to share innovative tools and technologies to build a better product and accomplish very interesting goals. So the first thing I'm going to talk about is the Berkeley software distribution, which is, we've got the three major logos here for FreeBSD, NetBSD, and OpenBSD. So we have OGBSD. So back in the day at Bell Labs, there were these guys building the system called Unix. Many of you are going to be familiar with this. And as they were developing it, remember, if you will, that it was originally developed for the legal department of AT&T to reduce printing expense and time. They developed into a full-featured operating system with certain goals in mind. One of the main developers, Ken Thompson, went to work at UC Berkeley in California teaching, and he had some grad students help him develop certain add-ons to the operating system. Add-ons like TCP and IP, sockets, the X and VI editors, and the BSD licenses. I'm assuming many of us are familiar with IP and TCP, the Internet Protocol, which undergirds all of our networking. And some notable users of the first editions of BSD were the military and, of course, AT&T. And this is an interesting fact because if we go back to the chart at the beginning, you'll see that as BSD is being developed parallel to Unix, Unix is taking many of the developments of BSD back into itself for development. And this is one of the great parts of the story. There are also bad parts of the story, including terrible wars over licensing. With free software, there's always a problem of who gets rights to do what and permission how. And in the late 1980s and 1990s, there was a series of legal battles because the competition between the free system of BSD and the proprietary system of commercial Unix led to some hurt feelings and unkind words. And essentially, out of that came the BSD license, which, if you're familiar with the GNU GPL, is also a free software license. It differs in a number of key ways. Basically, all the BSD license says is, we wrote this code. Please acknowledge that we wrote it. Don't sue us, and do with it whatever you want with it. There's no demand that you have to contribute code back. There's no demand about anything else other than don't sue us and say that we helped you make it. So when you're looking at code, my parents recently got a smart TV for the first time, and I went through and looked at the licensing. And there's all this BSD license code in there. Now, did Samsung contribute that code back? No, but they're free to use it in their product, and that's part of the point. So FreeBSD was developed in 1993, and the goal of the FreeBSD project in general is let's build the best server operating system that we can. Let's have the motto of the product is the power to serve. And there was a number of innovations developed in FreeBSD, specifically the port system, which is source-based package management. So with the port system, anyone can develop a third-party application like Mozilla Firefox or Google Chrome, package it in such a way and allow you to install it on your machine. Jails, which I'll talk about later. ZFS, which I'll talk about later. Beehive, which is a hypervisor similar to Shen. Capsicum, which is a security mitigation based on the idea of sandboxing. And a Linux compatibility layer. So today, if you go to install FreeBSD on a server, you will have the ability to run 32-bit or 64-bit Linux binaries natively on the machine usually without any problem. Sometimes it can be a bit iffy, but it is what it is. Notable use is Apple in Darwin, which undergirds Mac OS X, so basically all of the OS X products are based on BSD in at least a theoretical way. Netflix uses it for their servers. Sophos and Juniper use it as a foundation for some of their operating system. WhatsApp, basically it powers the WhatsApp app. Sony uses it for the PS3, PS4, and Vita. And the state of Ohio uses it for the ORNet, which I'm sure afterwards you can ask certain people around here about. So we have OpenBSD. Now these BSD projects are kind of different. They share code, they sometimes compete, and while FreeBSD is really focused on the server, OpenBSD is much more ambitious. In fact, the founder of OpenBSD, Theo Dirat, describes it as a research operating system in many ways. The idea of OpenBSD is let's build the best general purpose operating system based on Unix that's as secure as possible. And they take security very seriously. Some of the major projects that you may recognize from OpenBSD include OpenSSH, LibreSSL, CARP, which is for server failover, the PF firewall, and then a whole bunch of their own internal utilities. So if you install OpenBSD in a machine, you'll get an NTP server, an SMTP server, an HTTP server, et cetera, et cetera. And the reason why they have all these custom packages is because they looked at things like network time and realized this network time protocol is old and buggy and was written by some grad student 15 years ago and has all these security holes in it. So we're just going to start from whole cloth, re-implement what we need to, and cut out everything else. So the OpenBSD project takes a very radical approach to security. That is, every mitigation that goes into the project, every mitigation that goes into the kernel is not optional. It's all on by default. I don't know how many of you are sysadmins or have experience with Linux at all, but setting up things like GR security and SE Linux can be very difficult. In OpenBSD, you don't have to set anything up. It's all in there in the default install. And that means that there is no backwards compatibility. In fact, they take a point of pride of saying there is no backwards compatibility. When you update, and you will have to change your configuration and you'll have to do things because they always want to move the ball forward. If anyone has experience with Windows, you may have noticed the opposite design decisions at play, where backwards compatibility can be very nice for a project. It can also leave people in the past. And OpenBSD also has an influence really low level. There's this paging protection that was first developed in OpenBSD, where the system cannot simultaneously write and execute code. They went in low-level C and changed basic functions to make sure that it would avoid errors and security flaws. And there's a number of technologies which are used elsewhere, like the PF firewall and OpenSSH, obviously, and LibreSSL. It's used at a lot of universities. It's commonly used as a firewall system. I've run it on my desktop for a number of years, and it's a really great desktop operating system. It's actually really usable and a good experience. It's used by Adobe, governments, ISPs, VPNs, cool kids, etc. And one way of kind of extrapolating out from just a list of the mentality of the OpenBSD project is that they're trying to bring all software forward. They're going to be at the front of the pack at the vanguard saying, whatever is the most secure, we will implement it no matter the cost. They're the extremists willing to die on the field in no man's land. And a great example of this is their pledge project. So they were looking at their code, and they realized that in the POSIX standard for Unix, there is no, well, let me put it another way. Every command, it's like ls or cat or echo, has, by default, access to all the system calls. And they realize this is a huge attack surface. So what we're going to do is we're going to go into every single piece of code that goes into the operating system and whitelist what system calls are allowed. So for example, in cat is only allowed access to the standard I/O and to know where its path is. It can't execute code. It can't do anything besides those two system calls. Right now in the current release, they've done 70% of the code has been pledged. By the next release in 6 months, all of it will be pledged. And that means that they have basically solved that problem, at least in their minds. How many of you even know what the year 2038 problem is? Oh, good. Okay, great. So I was afraid I was going to put you all to sleep. So it's basically Y2K for Unix. So 32-bit time is set to have a big problem in the year 2038. I think it was like 6 years ago, OpenBSD solved that issue. And the reason it's important to solve it now is because embedded systems and applications which are being developed now have a long lifespan, et cetera, et cetera. All of a sudden it's 2038 and your pacemaker breaks because 32-bit time. We don't want that to happen to anybody. So the other big family of operating systems I wanted to talk about is the Solaris family, specifically the free version of Solaris called Illumos. So Sun Microsystems took the code from BSD. In fact, Bill Joy, who wrote VI and TCP and all these other things for BSD, went to work at Sun, and they developed their own operating system basically based on that ++. Now, in recent years, Sun was purchased by Oracle, and the Open Solaris project was taken closed source. This left a lot of the technologies in a weird legal limbo, and a bunch of the old Solaris people decided, we're going to start a new project with a new name. That new name is Illumos. Not the easiest in terms of namespace remembering, but it's a good name. That's a decent enough logo, you know? And the two major Illumos distributions, I guess, the two major Illumos projects you should know about are SmartOS, which is used for virtualization, and OmniOS, which is a general server operating system. So Illumos developed ZFS, DTrace, and Zones, all of which I'm going to talk about in a minute. And the main companies are Nexenta, Joint, and OmniTI. An interesting fact about the Illumos projects is that their users tend to be their developers, so companies tend to develop these products as internal tools and then simply release them for open source contributions. They're not seeing a ton of use outside the companies, mostly because like Joint, who develops SmartOS, offers it as kind of like a crazy Docker on steroids as a service situation. So there's a lot of websites and things being powered by these products, but not a lot of companies using them directly. So now here's the fun part. So this is a diagram of how ZFS works. And ZFS stands for the Zettabyte File System. It was developed at Sun and then ported over to FreeBSD, and now it's propagated through the BSDs. Mac kind of supports it now, and Linux is gaining support. And the reason why is because it's really innovative and really cool. So if you're a sysadmin, or you know anyone who's a sysadmin, or you have critical data, you should look at ZFS. This diagram I really like because it clearly mentions that whatever you were using that wasn't ZFS will be your former file system, and that is very true. And you can see by this chart that in a traditional way of setting up the file system, you'd have this. With file systems, with ZFS, you were allowed, I guess I'll just walk in front of the light, to have these storage pools, which can take any number of physical devices. So you could have, you know, I don't remember the limits, but I think it's like 50, 100, however many drives you have can go in a single pool, and then you can break up off of that for your own convenience. But there are other features of ZFS. It has data integrity checksumming. So every time any change makes, because it's a copy on write file system, you're never overwriting anything. It goes to another node on the disk and writes again, and keeps a checksum to make sure you haven't lost any data. One of the promises is that there's no data corruption with ZFS. Maybe it's true, maybe it's not, but it's a hell of a lot better than what most people are using. It's really easy to use. The commands are really easy. There's some graphical tools. It's mostly command line driven, but doing things like an incremental snapshot where I take a picture of today and then tomorrow and then the next day and only build on what's changed allows you to get really nice, even backups without paying too high a penalty in disk space. The pooled storage from the last diagram is really, really convenient, especially if you want to do a NAS or a SAN or any kind of major storage thing. RAID Z or RAID Z is basically the software RAID that comes as a part of ZFS. So to use ZFS for RAID, you don't need a RAID controller. You just need disks and RAM. That's one of the things, is you need RAM to use ZFS. I believe it's 2 gigabytes of RAM for every terabyte of data. That formula might be off. I should put it on the slide, but it's easy to look on Wikipedia and find it out. And by the way, did I tell you the killer feature of ZFS is it supports a maximum of 256 quadrillion zettabytes in a single ZFS file system. And remember that 1 zettabyte equals a billion terabytes. So the design decision was, it's going to be the future sooner than we think. We need a file system for the future. One of the other interesting things that ZFS can do is ZFS send and receive. So let's say I want to make a remote backup. I can say ZFS send all my snapshots from the last month. And it really is as easy as just a normal Unix pipe command. Use ZFS send. You can go over some kind of networking protocol like netcat or whatever, and then the other side receive that data into a remote place. And also encryption is really easy. Like on FreeBSD, if you ever set up a FreeBSD system, just doing ZFS on the root with full disk encryption is the easiest thing I've ever done. And it also does automatic deduplication. So yeah, I at least got one fan out here. That's good. Copy on write. So instead of overwriting the data again and again, we're going to have data written here, data written here, data written here, data written here, and then just the system is smart enough to seek back and forth. You pay a little bit of a penalty in total amount of space, but it prevents any kind of corruption or accidental overwriting of the data that you're trying to protect. Okay. So now we're going to talk about jails. So jails were...
I got a question about ZFS.
Yes.
Would it be fair to tell someone who's not familiar with ZFS that it's like version control for your files, basically?
It can be like that, yes. Yeah. There are file systems developed specifically to do that. ZFS lets you do that. And the snapshotting, like Mac supports ZFS, for example, on external disks, not on the internal drive. And it makes me really sad because I wish I could just have these snapshots of my system every day because it's so convenient to just roll back to a previous iteration whenever I do something that is stupid, because I do stupid things frequently. The reason why, and I actually looked into this for the presentation, the reason why Mac supports ZFS, because remember it's based on BSD, so it has the code, but doesn't support it on the root directory, is because the file system support in Time Machine is hard-coded, and the engineers couldn't be bothered to include ZFS support. So Time Machine is really nice front end, and it would be really cool to, like fly in like Jurassic Park to the file system and find whatever. But it's really sad, and Apple should change that. So there's a really good paper you can find if you search Sane 2000 and Taming the Almighty Root for the original paper about jails. So how many of you are familiar with basic Unix file permissions? Okay. So jails is the idea of saying chroot is not good enough. We need a better system of managing permissions. So what we're going to do is we're going to take, I'm just going to say things to keep it general. We're going to take things and put them in jail. We're going to imprison them. They're going to be locked down. We're going to restrict what they're able to do. So instead of just having file system level permissions, in a jail you basically have like a thin virtualization or a light virtualization. And I'll show a diagram in a minute to explain that. Where essentially in a jail, like let's take a practical example. So I'm setting up a mail server or a web server. I set up a web server in a jail. An attacker breaks into the web server. They can't get out. It's not possible. In fact, I can see in to see what they're doing, but they think they're in the root of the file system because in the jail, it looks as if it's the entire system. This is really nice, and I hope the diagram next explains better than I can. So you have your hardware, and you have the kernel. So let's say it's FreeBSD. This is a jail, and this is a jail. So they share the same host kernel, but can have different user lands with different processes. So you can segregate, you can control what IP addresses the process can bind to, the sockets, all that stuff. And it's also really easy to do, which is helpful. So let's say you're a startup and you're going to have a DigitalOcean droplet for your mail server. Put it in a jail. It doesn't cost you anything because the virtualization is so light, you barely notice it's there. And that's the main advantage of jails, is you can get this extra layer of security, this sandboxing, this virtualization, at a very low cost. However, jails only go so far. So jails came from BSD. The people over at Sun were saying, yeah, jails are cool, but why can't we do more with jails? Remember, this is before Docker existed. So people are like, what if we wanted like Windows in a jail? How would we do that? Well, you can't, because remember, a jail shares the host OS between all the different jails. If you have a FreeBSD version 10, you can't have a FreeBSD version 9. It has to be the same kernel. So at Sun, they said, let's go deeper. So now let's go deeper virtualization. So now you could have a Smart OS machine, for example, and on the Smart OS machine you have some services running, some processes running, and then you know what you're going to do? You're going to have a zone that's a Linux zone. And you know what? Inside that zone, that's going to be a host for another zone, which is a Windows zone, because you need that for some reason. It costs a little bit more in terms of resources, but it's still much lighter than a lot of the containerization, virtualization alternatives out there. And I know SmartOS does this. I don't know about the other Illumoses, but it also now interops really well with KVM. So you also get all the advantages of Linux KVM on the low level. A lot of people talk about zones as sort of like a higher level virtualization. I'm not a virtualization expert. I just think it's cool, so I included it in my chat. I'm hoping that those of you with needs for virtualization will see this and be like, this is interesting. I'll go investigate this. And also, if you thought ZFS was cool with the version control-like aspects in the file system, you can do the same thing on the virtualized kernel level with zones. So you can take snapshots of your zones and rollbacks and all sorts of things. Complicated, too much for my humble developer's brain, but presented to you as a gift from Sun Microsystems. And here is a comparison between just normal Unix and zones. So you see you have the hardware, you have the driver, the host kernel, the host operating system, and then you can have global zones and guest zones. And a lot of times these will just be normal, like this would be actually similar to a jail. But what if we wanted this to be Windows, or we want this to be Mac OS, or whatever? And so it gives you a lot of flexibility with the system without having to leverage some third-party thing. Like this is built into all Illumos. So if you install OpenIndiana, Omni OS, Smart OS, this just comes with the operating system. And I guess at this juncture, I should explain something I glossed over at the beginning. There is a fundamental design difference between BSD/Illumos projects and Linux. In Linux, you have the kernel, which is developed by Linus and his team. Then you have GNU with old Richard and his team, Cult, whatever. And they interop really well, right? But it's a hodgepodge of this piece and this piece and this piece, and it can be really fun. I'm running Linux on my laptop because there's corporations that pour lots of money into the year of the Linux desktop, so you can have a much better desktop experience, However, there's certain things that are missing. Like when I'm on Mac or when I'm on Linux, I miss the level of documentation that the projects like OpenBSD provide. And to the point where I sometimes install the BSD man pages on my Linux machines because they're so much superior. And part of that is in BSD land, you have the product. There's not the BSD kernel and then the BSD user land. It's all one finished product that is presented to you. And then you can have third-party applications if you want. But everything you need, say with OpenBSD, to do a server, they include. It might not be what you want. It might not be Apache, but they have a mail server. They have a HTTP server. They have everything you need to do whatever you need to do. And it's developed by the same team that develops all the low-level kernel optimization. So when there's a security problem or anything else, there's a much more structured way of pushing out updates, issuing warnings. It's basically just more organized in general, and that can lead to a more conservative development model. But in my mind, it also might lead to a little bit of a better product, but it depends on what you want. Again, this isn't a Linux bashing talk. It's just there are other things out there that are also interesting. So the next thing I'm going to talk about is DTrace. And DTrace is really complicated, so I decided to put the chart up first. So DTrace is a system profiling tool that was also developed at Sun and is now in Illumos that the FreeBSD people took and made their own. So now it's in Mac. It's not on Windows. Maybe. No, it'll never be on Windows. I forgot. But I believe the only thing keeping it from being on Linux is weird GPL licensing issue stuff. But basically, DTrace is a massive rootkit that allows you to put probes everywhere in the system. So you can put probes in the kernel. You can put probes in user processes. You can put probes in the file system and profile everything, top to bottom, with one DSL, which they call D. It's not related to the other D programming language. It's kind of like awk in the way it looks. I like awk, so I like it. If you're a pen tester, you should read up on DTrace, and you can exploit all the Macs. Oh, where'd my Oh, I skipped over it. Yes. So this is one of the latest technologies developed. It was also developed the same release. Solaris 10 released both DTrace and ZFS. Good job, Solaris. That was a good release. So it's a dynamic system analysis tool that has its own DSL. And it's production safe. So you can have a process running, investigate it, do things to it, and it's guaranteed to not mess up your production system, which is a really big guarantee that they take very seriously. So it limits some of the power and expressiveness of the language, but given that it's already a massive rootkit, how much more massive do you need it to be? Why not be production safe? And it can see user activity, library calls, system calls, kernel functions, kernel VMs, VM processes, and like I said before, it's the default rootkit for Mac OS X.
In the release doco, when Oracle Sun announced this tool, they claimed that there was no impact on the system when you lit up the DTrace components. How does that even work?
I do not know. I know it is magic,
Okay.
and that is the case. And one more thing about DTrace before I move along. And I know I'm pressed for time, so I'll wrap up here. But one of the things that's really interesting is, I don't even remember all the different ones. There's strace and truss and a bunch of other tools you can use. DTrace basically lets you do all of this in one box. So you learn one tool for all your system profiling. And I, again, sort of in the more BSD mindset, I would rather learn one tool that does them all than try to remember all the differences between the different implementations of grep or the different implementations of RM across the different Linuxes. I'm sure you all heard about the fellow who destroyed his whole hosting provider. That's actually impossible in BSD/Illumos because of this design decision to focus on security. Because that behavior is undefined in BSD and in Illumos, when you try to RMRF/, it tries to begin in your present directory, which is technically illegal according to POSIX. And so that behavior is undefined. As they say, we'll just stop, and then it stops. So there's no way to bork your whole hosting provider because they thought ahead. Thinking ahead is good. All right. So here's the final section, tu quoque. So why am I talking to you about this? Take these tools. Use ZFS. It's great. It'll save your data. Use DTrace. It'll help you exploit Macs. Explore. Jump into OpenBSD. Install it. It's really easy. All the BSDs have text mode installers, which are totally easy to use. I installed FreeBSD in this laptop in under 10 minutes. It's great. And the best part is most of this stuff is being ported to Linux and all the other systems that you love, so you don't need to become a nerd like me. You can just use the tools and profit. If there's any questions, I will try to take them as quickly as I can. Thank you all very much. All right.
We're going to take about 4 minutes. If you want to grab a smoke or use